Laminated magnets is another manufacturing offering that many magnet manufacturers will offer in terms of how to make systems more efficient. So how do I reduce the losses on my magnet material overall? Can I laminate my magnet material just like I laminate a stator stack, for example? We do those laminations in the stator stack to reduce the eddy current losses throughout the axial length of a stator. Can I do those same things with my magnet? Well, sure, and that's a process which we offer. So it increases efficiency through further reduction of eddy currents. We make those layers as thin as possible, less than 20 microns for maximum energy density. Because again, looking at your stack fill, we know with stators, I may only have a mid-90s stack fill because I lose the needed material when I'm putting the insulated layers along that axial length of my stator. Same thing happens when you're laminating a magnet. We're putting an insulative layer and we're removing the core material, but you still can achieve a very high stack factor for maximum energy density when we're using less than 20 microns insulating layers. Performance at temperature is well above 200 when we're doing this with samarium cobalt. The magnet layers can be 0.5 millimeter and up, so you can make those wafers of magnet all the way down to 0.5 millimeter, and we can make them 1 millimeter, 2 millimeter, whatever's going to be best for your application. There's obviously a cost to benefit ratio that you need to look at, because as you add more and more and more thinner layers, you will obviously have a return loss on the increase in efficiency overall. So something to work with us on when you're designing the system. It's developed to solve customer needs as needed, and we can use samarium cobalt or grain boundary diffused neo or regular neo. We can do this with any fully dense sintered magnet material. The benefits of those are shown right here on this slide, just to bring in a little bit of a FEA analysis. Engineers love FEA analysis. This is how we live. It's what shows and validates our data and our theories and our concepts. So we know that through most FEA, red is bad, red is a little bit of a higher number, blue is good for losses. What we're looking at here are joule loss distributions of a 4-pole magnet on a high-speed rotor. You can see that as we laminate more and more and more, we get less red, more blue. So we're going to operate at a higher efficiency standard overall by removing those joule losses on the magnets. So that's really the main takeaway of this slide. You can laminate just axially, and you get a decent bang for your buck when you just laminate axially across the length of the rotor, or you can continue to laminate axially, side to side, through the DOM. You can laminate all three directions if needed. It just depends how much cost to return ratio you want to have for your system at the end of the day. And that's really the point of this slide.